Hello there and welcome to Chemcracker. Today we're going to be demystifying the mole. Yes, the notorious mole. A lot of students have problem with this concept, but we're going to be demystifying it today. Now before we go into calculations and using the mole, the most important thing to do is to understand the function of the mole. Then we need to know the definition of the mole, and then we can use that definition relationship to do calculations. Let's talk about the function of the mole. Now, the mole is just a way of measuring amount of substance, right? Now, when you go to the supermarket, depending on what you buy, it's measured in different amount. If you go to buy some flour, you can't count the number of flour particles. It's better to wait. You might buy, say, 1 pound or 1 kilogram of flour. If you're going to buy syrup, they sell you by the liter, the volume. If you're going to buy oranges, they might sell you by the dozen. You count the number of items. Now the mole is similar to this. It's very similar to a dozen, only that it is a much bigger number. But 1 mole is a certain number of particles. It is a way of counting particles. In fact, let's look at the definition of the mole. So let us look at the definition of the mole. The mole is the amount of substance which contains 6.023 times 10 to the 23 particles. It's a big number. Let's write it. That is 6023 and then 20 zeros after that. 1, 2, 3, 4, 5, 6, and 2 more. That's a huge number. But do not be intimidated by that. Despite that, it's just a way of bundling the particles together because there are lots of particles in a small amount of substance. So it's a big number, but do not be intimidated by it. Let's look at how we use this number. Let's look at this number. This number is known as Avogadro's constant. Avogadro's constant. We're going to look at this guy later on, some more. Now, when we talk about particles, there are different types of particles. Okay? Depending on the nature of the substance, the particles could be atoms, it could be molecules, it could be ions, or it could be formula units. Now, ions and formula units, those apply to ionic substances, while atoms and molecules will apply atoms to metals and atoms and molecules to covalent substances. So depending on the nature of the substance, you will have different types of particles. Now, what does this mean mathematically? If I express this mathematically, it's saying that 1 mole is equal to 6.023 times 10 to the 23 particles. That's what it's saying, and that's what we need to remember for the definition of the mole. The definition of the mole is establishing the relationship with numbers of particles, because that's what the mole does. It counts particles. Now, because different substances exist as different types of particles, then we have to look at how the mole applies to different types of substances individually. So, magnesium exists as atoms. So 1 mole of magnesium has 6 times 10 to the 23 atoms. Now 6 times 10 to the 23, that number that I'm using there is simplified because 6.023 goes on and it's very complicated, so we just simplified it to 6 times 10 to the 23. Okay, we've rounded it off. Now, that number is also called Avogadro's constant, that's L there. If we look at water, water exists as molecules. So 1 mole of water has 6 times 10 to the 23 molecules. Sodium chloride is an ionic substance, so this is a formula unit of sodium chloride. 1 mole of sodium chloride has 6 times 10 to the 23 formula unit. Now, let's see if we can apply this to do calculations involving the mole and different numbers of particles. Let's look at this question. The question says, how many atoms are present in 5 moles of magnesium? Now, before I go into the calculation, I want to talk about the general approach to calculations involving the mole. Now, the most important thing for you to do is to know and understand the definitions, because those give you any formula you want. They establish the relationships that you need to work out your question. Okay, so if we look at this question, let's try and figure out what relationship they're asking us about. Now, the question says how many atoms. So let's just circle that. That's the question being asked. How many atoms are present in 5 moles of magnesium? So you're given some information. So you're given moles and you're asked for atoms. So the relationship that you're looking to link is the relationship between atoms, which is a type of particle, and moles. Now, where do you get that relationship from? That relationship is in the definition of the mole. It says 1 mole is 6 times 10 to the 23 particles. Now, magnesium there, that's a metal. So right away, our first step, the first thing that we're going to write down is what is the relationship between particles and moles. That's established there. We know that 1 mole of any substance, and in this case we're talking about magnesium, all right, 1 mole of Mg contains that number of particles, 6 times 10 to the 23 particles. Now, in this case, the particle is atoms, So, let's put that. Particles are atoms. Now, so we've established that relationship. Now we can proceed to answer the question. 1 mole of Mg is 6 times 10 to the 23 atoms. Now, let's look at the question. The question is saying, if I have 5 moles, how many atoms? So if I have 5 moles of magnesium, how many atoms will that be? Now I'm going to replace the question sign, I'm going to put a variable x. And so we can proceed to find x, right? So x times 1, if we cross multiply there, is equal to 5 times 6 times 10 to the 23. And x is therefore equal to 3 times 10 to the 24 atoms. As easy as that. So just a quick recap. The first thing you need to do is to establish the relationship which the question is asking you about. And then you use the definition as your first step in your calculation. It's established that 1 mole of a substance is 6 times 10 to the 23 particles. So 1 mole of magnesium is 6 times 10 to the 23 atoms. And then the question is asking you, if I have 5 moles, how many atoms? You simply do that, and by simple calculation, you come to your answer. Let's look at another question. This question says, how many moles are present in 1.2 times 10 to the 25 molecules of water? Remember our technique. We have to ask ourselves, okay, what is the relationship that this question is asking me about? Let's look at the information that is given. It's asking how many moles. So it's asking about moles, and it is given 1.2 times 10 to the 25 molecules. Molecules. So again, the relationship is between mole and number of particles. And so we know what established relationship that is. 1 mole equal 6 times 10 to the 23 particles. Now 1 mole of what? Water, in this case. And what kind of particles? Molecules. Okay, so we've established our relationship. Now we can proceed to answer the question. The question is asking how many moles. So we don't know how many moles, but it has given us that we have 1.2 times 10 to the 25 molecules. Notice my units The molecules are on one side, the moles are on another side. You don't mix the two, or else you have problems. You must have moles on one side, molecules on the other side. Okay, so let's replace our question sign with a variable x mole of water. Alright, and so again, we can just cross multiply and we can go to our next line. So our next line is going to say that 6.6 times 10 to the 23 times x is equal to 1 times 1.2 times 10 to the 25. Now, x is going to be equal to 1 times 1.2 times 10 to the 25 over 6 times 10 to the 23. And that is going to give us, if we're 20 moles. Moles, because let's look at x, where x was x moles. So we know that our units are moles. Don't forget to put your units. Now, if I look at this carefully, I can see that what I have done, essentially, I have used a formula without knowing it. In fact, I can derive the formula from this. Because if I look carefully, what was this? This number was the given number of molecules, wasn't it? That's what this number was. It was the given number of molecules. And this is Avogadro's constant. It's L. So, an x that we're finding is the number of moles. So from this, we can derive the formula that moles is equal to given number of particles over L. And just like that, we have derived a formula for working this out. So that we don't need to swat it. If we understand the relationship, we can derive the formula. And that's the approach that you need to take with moles. Derive the formula from an understanding of the definition that establishes the relationships. And that way, you will be able to understand the mole concept in a wholesome way and much more quickly. That's it when it comes to the definition, function, and usage of the mole. Don't forget to like, share, and subscribe to my channel. We're going to be doing a whole series on the moles, and this is the first video. Make sure you watch all of the videos to get a wholesome understanding of the mole. We're going to crack it.